Next, we will discuss the concepts of greatest common divisor and least common multiple, and we are going to refer to these in short as GCD and LCM. Here we have the definition of a GCD for positive integers a and b, which are, of course, non-negative. The largest integer d, such that d divides a and d divides b together, is called the GCD of a and b. Okay? And if GCD of a and b is equal to 1, which means they do not have any common prime factors, then we say A and B are relatively prime or co-prime. Now you have to be careful about here. To have this, A and B do not have to be primes themselves. Okay, for instance, 8 and 9, both of them are composite numbers. In fact, 8 is equal to 2 to power 3 and 9 is equal to 3 to power 2. However, their GCD is 1. The greatest common divisor of 8 and 9 is 1, which means they do not have any common prime factors, which is obvious again from these prime factorizations. And therefore, we say that these numbers are relatively prime or co-prime. Now, in the general sense, observe that when you write the number a in its prime factorization, p1 to power a1, p2 to power a2, etc., up to pn to power an. And if you write b in the form p1 to power b1, p2 to power b2, etc., up to pn to power bn, for some primes p1 to pn, where the powers are non-negative integers, then you can express both the GCD and the LCM actually in terms of these numbers. In this case, the GCD, you are going to include all the common prime factors. Therefore, you're going to get the minimum of the two powers, A and B. Okay, so P1 to power A1, P1 to power B2, and in the common factorization, you would have, if A1 is smaller, you should have P1 to A1. If B1 is smaller, you should have P1 to B1. Similarly with all the other factors, therefore the GCD of the numbers A and B can be expressed in this form. And very similarly, we define the least common multiple as the smallest integer d, such that now A divides D and B divides D. It's the other way around. Okay, D divides A, D divides B was the expression in the definition of GCD. In the definition of LCM, we have A divides D and B divides D. So D is a multiple of both A and B, but it's the smallest such number. Okay, so we call this the least common multiple of A and B. And following the same logic, when we did with GCD, we can express the LCM of the two numbers A and B as P1 to the power maximum of A1 and B1, P2 to the power the maximum of A2, B2, etc. Okay, so let's see this on an example. Okay, and obviously, if you consider these min-max representations of GCD and LCM, you see I have the minimums in the GCD representation, and I have the maximums in the LCM representation. So consider the number A times B, that would be P to power A1, P1 to power A1, P2 to power A2, Pn to power An times P1 to power B1, P2 to the power B2, Pn to power Bn. So this means this is P1 to power A1 plus A1 plus B1 times B2 to power A2 plus B2 Pn to power An plus Bn. Okay, rather than separating these by A1, B1, if you separate them as the minimum and the maximum, you get the product of the GCD and LCM. Therefore, it should be clear that the product of the GCD and the LCM of two integers a and b is equal to the product of these two integers. Okay, here's a small example. Let's say the number a is equal to 120 and b to 500. And here you see the prime factorization of each of these numbers, and we can express both of them in this way. 120 equals 2 to the power 3 times 3 to 1 times 5 to 1. And 500 we can write as 2 to the power 2, 3 to the power 0, and 5 to the power 3. Okay, so 0 powers are allowed so that we can express them in the same prime basis. Therefore, we write the GCD as 2 to the power, the minimum of these two, so 2 to the power 2, and 3 to the power, the minimum of 1 and 0, so 3 to the power 0, and 5 to the power, the minimum of 1 and 3. Okay, so you get the GCD as 2 to the power 2 times 3 to the power 0 times 5 to 1, which gives you 20. Similarly with LCM, now this time around you get the maximums, 2 to the power, the maximum of 3 and 2, times 3 to the power, the maximum of 1 and 0, and 5 to the power, the maximum of 1 and 3, which gives you 3000. Now you see each of these components appear in either the GCD or the LCM. For instance, 2 to the power 3 is included in the LCM, and 2 to the power 2 is included in the GCD. Similarly, 3 to 1 appears in the LCM, 3 to the power 0 appears in the GCD. 5 to 1 appears in the GCD, 5 to 3 is in the LCM. This means when you multiply them, obviously you will get the product of the original two numbers.